There can be some cases where the header of the automatic doors is a structural member and we can solely attach to our jams. The tricky sticking point here is making that assumption without actually having that confirmation. One particular project we're working on, we were on a call with the door manufacturer, and they basically were saying that the structure surrounding their doors needs to be ultimately a rigid structure, and that, yeah, their header is anchored. So a couple things with this. First, we need to, our first assumption is going to be that the doors are anchored at the jambs and at the head. If we're having issues with that, then we need something from the door manufacturer or some documentation that states that their door header is a structural member and does not need to be anchored to our frame at their head. Now, if we do have that information and only need to anchor our jambs, we also need to make sure that that's called out specifically in our details. We've had past conditions where we've made the assumption that our door header is not anchored, but yet in the shops we hadn't made any specific comments on that. So most likely what happened during the installation, they went ahead and anchored the head. So just something to keep an eye out for. We really just need to start watching that whenever we're looking at conditions like that. Any questions?
Does that change the deflection limit of head? I'm assuming that's what the issue is.
Well, we were having, this isn't what we're currently dealing with. It's a similar condition. Actually, in what we're dealing with right now, we have like 20 feet of curtain wall above this. So we were able to solve the vertical deflection issue, but then we still had to deal with the out of plane due to wind. And we reached out and had a conference call with the door people, and they didn't have any specific, they couldn't provide us any limitations. They just said that the surrounding structure needs to be significantly rigid. So we're trying to bring down our deflection as much as possible in this case. This is an odd case, but we're going through the same process we would go through on any other project. Any other questions?
A little bit of the history of some of these automatic doors. Originally, whenever we started seeing those quite a while back, we started doing a lot of questioning about the head, and so some of them ended up being self-supported type structures at the head where they don't require connections into our header. Others were not. And then in addition to that, one of the things that I typically did in the past was I would ask our client for the shop drawings for the automatic door provider, and usually that's available at some point, and you can kind of see in there whether or not they're indicating any types of anchorage from their header, for support. One of the things, whenever we got into some of the talks, I think it was with Stanley as a manufacturer, they actually did provide us some limitations, and I think another company provided us a little bit of information about limitations too. They started indicating that a 1/2 inch, and I think that that's currently where we're at, with about a 1/2 inch limitation for the out of plane movement for operation of the door. One of the caveats associated with that is that there's a possibility of reducing the wind to a, say a 60 mile per hour, 70 mile per hour wind instead of the 90 mile per hour wind, with the thought process that, usually in a 90 mile per hour wind, people are rarely outside, and there's no operation of any doors that are going on. Everybody is actually kind of hunkered down and in a shelter location. And so that, brings about a possibility of reducing it down a little bit. And there's a little bit of a relief there for the deflection limit. One of the concepts that was brought up was, what about automatic doors for emergency locations, emergency hospital locations, things like that? And I still think that it may apply. That may be, why we should limit it to like 60 or 70 mile per hour, because usually, cars aren't even traveling in a 90 mile per hour wind. You can't operate a vehicle in a 90 mile per hour wind. There's no way to operate it. And it's only for a very short period of time here in the Midwest and in most locations where we have, the 115 mile per hour wind design criteria. I think whenever you get out to a hurricane location, even there, they evacuate people, and especially at hospitals, they try to shut it down, to where, there's no people coming in, they're sending people elsewhere. So I think that that's probably a good policy, to be able to allow the wind to go down to a more of a moderate gust, 60 mile per hour or 70 mile per hour, for the operation of the door limit, which is about half an inch from previous manufacturers.
Just to comment on that, that's ASD. We don't want to have 115 mile an hour and then drop that to 60 and then reduce that to ASD.
Right. Yeah. No, that's ASD. Right.
Also, to comment on that deflection limit with Stanley, because I was one who did a lot of that work with them. It was half inch for the overall frame. So just keep that in mind. It's jams plus header is a half inch. And then they limit it to 0.15 inch for the curvature of the header, vertically or laterally. So they kind of had two limitations. There's an email in there in the shared area that describes that.
So the header deflection plus the jam deflection can exceed 0.5.
Right. Yeah.
Is there any way that we can rely if it is, mechanically connected at the head? Is there any way we can potentially rely on the auto door framing itself for a little bit of stiffness?
The manufacturer actually brought that up and said that basically what's going to happen is that the surrounding frame is going to want to deflect, and the auto doors are going to want to stay in place. So it's going to put some weird shear on the connections to the head. And they told us that they really don't have any way of proving that out, that would be on us to do something like that. But again, in this case, we really don't have any limitations to work with, so we don't know what's acceptable and what's not.
So do you think it's safe to say going forward with any project that has automatic doors that we should just send off an RFI to begin the project, seeking for the allowable deflections for every door, automatic door?
I would say that it depends on the situation. I don't want to just on every project, okay, we have doors, let's get out an RFI and start this whole process. We may have a configuration and wind pressures that we don't need that we can just go through our design and everything checks out. So it's something unless we have to, I don't want to throw up a red flag and start tapping the brakes and having our clients say, what are you doing here? We've done this in the past. So it's going to be a case by case basis. So whenever we come across those situations, we can just talk about them and see what needs to be done.
And pending schedule of the project, we may not know what the auto door manufacturer is going to be until later.
The other thing I think we need to be aware of in cases where, let's say there is a structural header and we're not attaching the door header to the frame, We don't want to have a case where under full pressure the actual curtain wall frame or storefront is deflecting out an inch or so. Even if it's within the allowables, you're going to have a stiff auto doors with the frame above moving in and out. So it's almost, we need to just do sanity checks on that, making sure that we don't have some ridiculous deflections. Ultimately, at doors, we want to keep deflection down as much as possible.
I found on the ones that I run, if you do what we kind of described there, what Stuart was describing, if you back down to a service wind and design to 1/2 inch overall frame and about 0.15 inch of curvature of your header, usually you can get curtain wall to work out with, pretty, nothing crazy for steel, some C channels, some HSS tubes. I found that's the most conservative route, is to assume they're attaching it and slap some steel on the jambs and the header, and it's nothing too crazy. If we assume they didn't attach it and then they did, that'd be the bad one. And so I've found just assuming they attach it and design to those limits with the service usually doesn't cause a huge ruffle. The biggest thing with these is to watch out for auto doors with storefront around them. That's the immediate one that I try to catch when I bring in a job, is if I see storefront, I kick it back. So that's a big one, because there's no chance at getting, no matter what's going on, at getting those to work. So just kind of watch out for that too in this discussion.
Matt, whenever you kick those back and it's storefront, how do you, what's your language to the client?
So usually I start off, you have to look at the situation. If it's a small transom above it, I'd have to look and find some exact language, but essentially if it's a small transom, I've seen Stanley include transoms in their shop drawings. And I explained to the client that, these operable doors, we don't want to have large deflections in them because they can cause the parts and pieces to fail, as they see some of these, even just service wins. And so I explained that typically the auto door manufacturers have an entire package that includes the transom, and we can just design the jambs on either side of it. And I start there. If that's not possible, then I explain it the same way and say, hey, these deflection limits are usually very stringent to make sure that all these operable parts don't, kink and break. And storefront is not acceptable as a substrate. And then I usually, revert, if that happens and I get any kickback on that, or I get any, like, hey, that's going to be a big deal, then I bring in the manufacturer and I say, let's discuss with the manufacturer and, talk about their deflection limits and things like that, because then you have a third party essentially backing that, yeah, you can't attach this to storefront.
I would just throw a word of caution to on these outer doors. Stanley might be actually one of the only ones that does have a full engineered package ready to be presented as delegated design. But many times our clients are in a position, and we're dealing that on a project in Chicago. Many times our clients are left kind of out in the cold. We're trying to find a company that does the delegated design of these outer doors, because the company that they decided to go with for the outer door manufacturers, they don't have a report, they don't have any engineers inside, they can't really help them provide any documents for the delegated design. So and I had that in a couple of projects in the past where the client is kind of in a gray area and say, well, who does engineering on these doors? If the glazing contractor or the glazing consultant is excluding that from scope, and that's where we try to explain it, right? That there's so many moving parts, so many moving pieces that we simply couldn't prove that the load path is continuous, so that we would put them actually at a disadvantage. We would try to prove this on paper, but then their response is, okay, then who do I go to? Who serves my needs of a delegated design of the auto doors? And that's when it becomes kind of tricky, because Stanley might be one of the better companies out there that does have an engineering report that they can present. But there's a good number of other companies that they just, give our clients the impression that they're just selling the doors and they need to be engineered by somebody else, and that's a kind of like a tough spot for our clients whenever they're faced with that problem.
I think a good option for that, the Florida product approvals, to see what auto doors have Florida product approvals, because if it's been tested and accepted by Florida, most likely it's going to be able to be accepted just about everywhere. Or, at least they have some type of testing or engineering report, because they've done the due diligence to get approved to be used in Florida, which is, as we all know, a pretty strict state as far as what materials can and can't be used. That might be a good starting point is, hey, if it has a Florida product approval, I'd probably start with one of these companies, because
Yeah. And I think, and Stuart and Quinlivan chip in if please, but I think one of the problems too is that if we're sealing a set of calcs and including a test report for the auto doors, we're kind of including now the auto doors into our scope, into our sealed scope. So I don't know, Stuart, do you have any good ways to delimit our scope, but then also serve our client, or it just becomes too risky to include those?
Yeah, ultimately in the past, more than often, on the drawings, they'll block out the auto door and they'll basically say see separate submittal. And in that separate submittal, they'll package up all of the information, including the shop drawings for the automatic door and the testing that is required by the spec. So usually the specs require a certain amount of testing to be done and submitted. And so usually that's the process that takes place, and it takes us out of the liable position for the door. And usually it doesn't require a delegated design. But if we ever see an instance where we see the shop drawings and they have not blocked that out and we don't have information about it, that's whenever we start digging for information. And we need to make sure that we communicate well with the client to say, just FYI, there's usually specifications that are associated with that, with testing required, and we can't do a delegated design on door and parts. But I think that's a great idea, Kyle, in being able to go back to the Florida product approval, as a basis for, does a door work or not, or has it, been tested? Because usually the door manufacturers will try to get a Florida product approval based off of the testing associated with the door. It's unfathomable to me that a door manufacturer with lots of parts, just think about the roller part, and this roller that's vertical, and the pins and the connection devices for stabilizing that. It's unfathomable to me that somebody, an engineer, has not already engineered it and gone through the process of looking at it for loads. Somewhere along the way, the manufacturers has invested a lot of time and effort in getting the engineering done on this, and we just simply cannot reproduce in the amount of time that we've got the delegated design of all of these parts and pieces going into place. So usually it's a tested item, and we've got to point back to that.